Hi, Year 11, the final part of Booklet D, I'm sincerely hoping. Part 2 kind of looked at the sine and cosine rule, the area of a triangle, these kind of things here, and got us towards arcs and sectors. We did a bit of a tutorial on it, but never really looked at the question, so we're going to pick up there. Move on to some similar shape, similar area, similar volume, then go back and fill in a gap that we left: spheres, cones and pyramids. So a little bit to kind of get through here, but I'm sure we can do it in the next 20 minutes. So the last video took us to this page, page 19. Okay, arcs and sectors. Now just in the last video I introduced this, but let me just remind you of what's going on here. A pizza slice taken out of a circle is called a sector. Okay, on the outside of that pizza slice, this is an arc. So an arc is part of the circumference of the circle, and a sector is part of the area of the circle. So if I thought of this as a whole circle, if I was working out the area, pi r squared, I'd be doing that. Okay, if I was working out the circumference of the circle, it would be pi times the diameter, double the radius, so that. Okay, so pi r squared, pi d. However, if I want just the area of this sector, I would times the area of the circle by the fraction 82 out of 360, and the same fraction here if I just wanted that arc on the whole circumference, and that is what I was doing last time. Now we need to also be prepared to be given the answer, okay, and potentially have to work backwards to find maybe the angle, or maybe the radius, or maybe the diameter, something missing from the question, knowing the answer. The same can be said of something else we looked at in part 2, which is the area of the triangle using this trio. Okay, so using side angle and side, or the angle between the two sides, and calling them little a, little b, and big C, which would be between those two. Again, half AB sine C, and I've worked out that one there, but we need to be prepared to be given the answer and have to work out one of the sides, potentially even work out the angle, and we'll have a look at some of those examples in this video. So quick guide to the questions that I've done here and what I've done. Hopefully they make sense. At the top of page 19, in this one I'm asked for the perimeter of the shaded region. Now this is a bit weird. What I've done is I've drawn this down here because the perimeter includes this straight edge but also this arc. Okay, I'll start with the arc, the length of the arc. Okay, so the arc is part of the full circumference. So the circumference of the circle would be pi times diameter, but the fraction I want is 68 out of 360. So I've done pi times the diameter times 68 out of 360 and worked out that length there to be 6.2. Now this side, which I've drawn here, okay, you can see this arrow coming up here, I'm thinking, how can I work that out? However, what I've got is a triangle there, and there's a nice trio. Okay, side being a radius, angle, side. So those two are the same, 5.2, but I've got the side, know the angle, the radius. So I've used the cosine rule. A squared equals b squared plus c squared minus 2bc cos a. I've broken it down a little bit there, but hopefully you can follow that through to get the answer. 5.8. So the total perimeter of the shape is that 5.8, add that 6.2, 12 centimeters. That was kind of looking at the length of the side and the length of the arc. Let's do one now, very, very similar, but at the bottom of the page, looking at the area of the shaded section here. Again, what I thought about here is the area of the whole, if you think of this as a sector, so if I coloured that in and included all of that, I would be working out the area of the circle, but I just want this fraction of it. So the area of the sector is pi r squared, okay, but just this fraction, 126 out of 360, so pi r squared times that. I've dumped in the radius, and I've got the answer 19.4. However, if I just want the shaded area, I need to take that away, take it out of the sector. So how am I working out the area of this triangle? Well, it's not the cosine rule this time, it's the same triplet, but we're using that triplet to work out the area of the triangle. Half AB sine C, half times that times the sine of that, which is what's written there as 7.1. So area of the full sector, that, area of just the triangle, that, and this time I'm not adding them together like I was in the top question. I'm taking that away from that. And my answer is 12.3, and we're talking about area, so centimetres squared. Okay, next. Not often you hear me say this, but a nice simple one. They just want the length of the arc, AB. So how long is that arc? So if I could work out the circumference of the whole circle by doing pi d, but the fraction I want is just that 191 out of 360. So also be careful that it's pi d, so 3.1 is the radius, so that's where the 6.2 comes from. The diameter is double the radius. Another reasonably simple one, I would say. The only thing I thought was interesting here is that word there. Calculate the length of the minor arc PQ. Something I didn't really think about is there's two ways to get from P to Q, either this way or I could have gone that way. Because this is smaller, this is called the minor arc. If they'd wanted this one, it would have been the major arc, okay? So if I, again, to kind of give you that idea here, going this way, that's the major arc, but if we'd had a dotted line there, that's a shorter cut, so that would have been the minor arc. It's a small point, it's not one I'd overthink about. So the length of that arc there, think again, the circumference of the circle is pi d, the diameter is 24, because we're told in the question the radius is 12, so pi times 24, but the fraction I want is 70 out of 360, there it is. And a little bit, I guess, something to think about is, how do I get the area of this sector, the larger of the sector, so not the kind of pizza slice? Well, I either work at the area of that and take it away from the circle, or probably an easy way is to go, well, if that's 70, that angle, the remaining angle is 290. So there's the area of the full circle, but the fraction I want is 290 out of 360, because I'm looking at the bigger chunk there. And there it is. This is a belter. I don't want to spend too long. I could spend an hour going through this. However, they want the area of this. Now, I identified this as being a sector, so I thought, well, I can get the area of the whole thing there. All I need is the radius and the angle, but I don't know the angle. And then I could work out the area of this triangle, and I thought, and take it away from that. But to get the area of that triangle, I need a triplet, the kind of that triplet. So I'm told in the question actually that is 3. So you can see I've kind of drawn that there. So I know that 3 and I know that 7, but again I don't know that angle. So that angle is important to working out the area of this and the area of this. Which is why over on the side here, 8 marks. I think they're being a bit unfair. I think it's worth a few more. I've kind of drawn that triangle here, but we are told in the question how long this side is. AD is 3 centimetres. We're told this side is 6 centimetres, and the 7 is actually already on there, so we know 3 sides. And this is the very, very first time in this booklet that we're going to use the cosine rule to work out the angle. Okay, knowing the 3 sides, it's unusual, probably the most unusual type of question, but we're going to call that angle big A because that's the angle that features in the cosine rule, and by default that becomes little a, little b and little c. So anywhere I see a little a, I've put in a 6, a little b is 7, little c 7, little b 7, little c 3, and the only thing I don't know then is cos big A. There's an example of how to do one of these in part 2, go back to it, okay, because I don't want to talk you through all of this, but I come down to using this rule to find out that the angle there is 58.4. This then dumps in here, okay, to work out the area of the sector. Pi times r squared times, and the fraction I want is 58.4 over 360, so I get 25. I've probably rounded to 1 decimal place, and it's come out to be 25.0 to 1 decimal place. And here the area of this triangle, half a times b times sine c. So using that triplet, and I get 8.9. Take that out of the sector to leave just the shaded part, so take that away from that, and there's your answer. Another chance then underneath to work backwards. I'm trying to find this angle. I'm told that the radius is 10, and I'm told that the area of this is 65 centimeters squared. So I've written out the area formula: pi times the radius squared, pi r squared for the whole circle, and then the fraction I want is, well, I don't know the angle, so I'm just leaving it as theta over 360, but I know the answer. Okay, that times that is 314, so it ends up being 314 times that divided by 360. Then a little bit of algebra. The opposite of divided by 360 is to times that by 360, and the opposite of that times in that, 314 times in that, is to divide by 314. So 65 times 360 divided by 314 tells me that that angle is 74.5. Okay, really quickly. Similar shapes. Okay, looking just for that word in the question, there are two similar shapes. Okay, or they might be drawn or just described, but find that word similar. It'll be there somewhere in this paper. Okay. Once we know we've got similar shapes, I'm looking for an equivalent side on both. Here I've got the 5.6 and the 8.4. Allows me to work out a scale factor. Big divided by small is 1.5. Okay, to work out x, times by a scale factor. To work out y, divide by a scale factor. And that's what I've done. There and there. Times by my scale factor, divide by my scale factor. Okay, more interestingly than just basic ones, we need to talk about area and volume scale factors. So, in fact, let me just quickly go back and explain what I've said here. Remember, if I'm talking about areas, to work out the area scale factor, I have to square the scale factor. And if I'm talking about volumes, the volume scale factor, I have to, that shouldn't say squared, right? Change that in your booklet, that should say cubed. Big mistake there. Okay, so I need to cube the scale factor to get the volume scale factor. Working backwards, say I've been able to work out the area scale factor, but I actually need the scale factor, then I've got to do the opposite and take the square root of that to get that. Or similarly, the cube root of the volume scale factor with the scale factor. Now, how does that play out in the question? Let's have a look. So in this one, I'm told two similar, put it in bold, highlight for me. Pyramids are volumes, so these are the volumes, not the sides. So if I divide big by small, what I'm working out here is the volume scale factor. However, they go on to mention working out heights. Alright, the height of the larger one is 25. What's the height of the smaller one? Well, I don't want to be using the volume scale factor there. I want to be using the length or the main scale factor. So there's the volume scale factor. But to get the main scale factor, I need the cube root of that, which is 1.1 to 1 decimal place. The height of the smaller pyramid is what I need, okay, to find out. And given that the larger one is 25, so to go from larger to smaller, I'm dividing by my scale factor to get 22.7. Very, very similar one here, but with areas. I'm told that two similar shapes have the following. Area 700 and 140. So by dividing big by small, I'm getting the area scale factor. Not what I need in this question. No, what I need is the scale factor, because we're talking about perimeter, which again, like height above, the perimeter is a length, right? So if this is the area scale factor, the scale factor itself is the square root of it, which is 2.2 to 1 decimal place. Another slight difference to the one above. I'm told the perimeter of the smaller shape and want to work out the perimeter of the larger shape. So the larger shape, I need to take the smaller shape and multiply by my scale factor, okay, to make it bigger. 83 times 2.2, which is that there. Another one that doesn't kind of go into areas and volumes, it's just an odd shape, I suppose. What I didn't like about this is they put the big one on the left. I always hate that. But anyway, there's a pair of sides that I know that 4.5, the equivalent side on this one is 3. I always do big divided by small, even though the big is on the left. Big divided by small, so my scale factor is 1.5. To find x, this is the big one, so I'm timesing that by 1.5. And to find y, I'm dividing that by 1.5, which is what these two calculations there are. Now, an alternative way to ask you about area or volume scale factors is to talk about, I guess for area, the cost of painting something because you paint an area, or the cost of putting turf down on a lawn because you're turfing an area of lawn. So again, I've put this note, as the area is painted, we need to use the area scale factor. What the question is saying is, it costs £3.40 to paint this one. How much will it cost to paint this one? So it's not just a case of taking the £3.40 and times in by that scale factor, because that's the length scale factor. So what I've said is, well, actually, I need the area scale factor, which is the scale factor squared, 1.5 squared, which is 2.25. So whatever cost it was to paint the small one, I'm multiplying that by my area scale factor, and I get £7.65. Okay, that's the end of the booklet. I did miss out in part 2 spheres and cones, etc. So with my last 4 or 5 minutes here, I'm going to go back, just take a look at 1 or 2 of them. And I'm on at the top of page 11. Again, this is taken from the formula sheet. The volume of a sphere, okay, 4/3 pi r cubed, and the surface area of a sphere. The volume of a cone, and the surface area, or the curved surface area of a cone. However, I rather think of that, this one here, 1/3 pi r squared h. Well, that pi r squared is just the area of that, so I'd rather think of that as 1/3 times the area times the height, and I'll explain why in about a minute's time when we come on to the second question. But I'll blast through a couple of them. This one, it says, what is the total surface area? So what have I got? Well, what I've got is, I've got half a sphere with a circle, a face, there's a circle there. So break it up. The surface area of the sphere would be this. I've copied that, 4 pi r squared. I know that the radius is 29, so I've worked that out. But that would be if this were a full sphere, a full ball. It's not, it's half. So I've got to half that surface area to get that. Then I've separately considered the top circle. The area of that circle there is pi r squared. Using the same radius of 29, pi times 29 squared is that. Add the two together, total surface area, 7922.22 to 2 decimal places. I don't know why, I normally do 1, but there we go. 1 or 2 decimal places for finding decimal. Okay, we're not told how to work at the volume of a pyramid, so I've kind of used my intuition here a little bit. Okay, if the volume of a cone is 1/3 times the area of the base, pi r squared, times the height, then I'm assuming the pyramid is 1/3 times the area of the base. But because this is a square or a rectangle, that's just length times width times height. So what I'm told here is the area of the bottom of this pyramid is 13,200 and the height is 460. Calculate the volume. So I've gone with 1/3 times the area times the height and got this huge answer in centimetres cubed. Then I spotted the dodgy bit. Give your answer in meters cubed. Not as easy as dividing by 100. I know there are 100 centimetres in a metre, but a 1 metre cubed would be 100 times 100 times 100, which is actually 1,000,000 centimetres cubed. So I'm dividing that by 1,000,000. Okay, this guy. Another one where they want surface area. There's plenty of marks even if you don't get it all right. Okay, you should spot, look, this is a cone, so I need the surface area of the cone. That's something I can copy from the front. The formula is given to me, it's pi rl. I'm in the question, I'm told that the radius is 11 and that the length of that, which is what I need, is 13. I don't actually need the height here, I need the length, which is 13. So I've got that there. A bit more awkward is the surface area of the cylinder. Again, we did this a little bit in numeracy, but if you unwrap that surface here, that curved surface, that becomes a rectangle. And the height of that rectangle is 17, but the length of that rectangle is equal to the circumference of the circle, which is pi d, where the diameter is 22. So I get a length of 69.08 and a height of 17. So the area is length times width for the rectangle, that times that, which is this, and the total surface area then it add those two. Now, I'm not even sure if I meant to do this, But I wondered whether we also needed the area of the bottom. We don't need this because you wouldn't see this, but you would see the bottom kind of if it wasn't placed on a table. So I've also done pi r squared and worked at the area of that circle and added that on as well. I don't know if I was meant to. Okay. I'll show you that. Okay. What they've done here is they've given me the volume of half a sphere. So I've written down, here's how you would get the volume of a sphere, but because it's half a sphere, I've divided it by 2, and I've put the answer. What would I do? I think I would take that divide by 2 there, and times that by 2. Then I'd work out 4 over 3 times pi, and because that's times in the r cubed, I would divide whatever my answer to that times that was by that. That will tell me what r cubed is. Take the cube root, and that will tell you r. And the final one. What am I looking for here? A bit of working backwards, okay. I'm told that the total capacity or volume is 1,244 cubic centimeters cubed. I know the volume of a cylinder is pi r squared times the depth, and I know the volume of the cone. I've copied it from the front. Okay, so I've written that the volume of the cylinder using 5 as the depth times the volume of the cone is equal to that. Pi times 5, I don't know r, it gives me 15.7 r squared, and here I've times everything together again by r squared, which is that. Added those together to make 34.54 r squared. The opposite of times in by that is to divide by it, which is 36 to 1 decimal place. So r squared is 36, so r is the square root of 36, which is 6.